Hello, my dear NEET warriors. Welcome to the new year. Welcome to the first class of 2024, especially for physics. And I hope you have already started your journey. I hope you have made up some new resolutions and you are ready to take it to the next level in the Super 6 series. Super 6 series means 6 days of the week you're going to have class, and on Sunday you're going to have a mock test and also quizzes on Telegram on the weekend. So make sure that you attempt the mock test as well as those Telegram quizzes. So in the Super 6 in the Super 6 series, we started off with ray optics and we did quite a few things. Like if you remember from last lecture, we talked about images, we talked about reflection, image formation, field of view, image velocity, multiple mirrors, all these things, curved mirrors. Then we also went to the concept of refractive index and also, total internal reflection, the concept of mirages, apparent depth, apparent shift, multiple layers of liquids. All these things was done in the ray optics 1, and then I said that we'll have a break and then we'll start with the next part, and that is curved surface refraction, then lenses, and then prisms, and then optical instruments. All right, so I hope you have seen the session before. In case you haven't, let me just tell you where it is available. As you watch the NEET English channel, just make sure you go to the live section and you can go back. You can see all the amazing teachers out here conducting all the classes for you. You can see this is the Ray Optics 1 class. All right, I have done this. It was a big marathon, 4 hours. So today's marathon might not be that big because not much is remaining. But yes, please watch this in case you haven't watched that. And if you have watched that already, give me a thumbs up in the chat box. And also smash the like button of today's lecture. Make sure you do that. Yes, please start smashing the like button. I would love to see all you people in the chats as well as in the comments in case you're watching it recorded. Hi Sensei. Hello Joran. Hello Pandu is also here. Good evening. Good evening. Hello Samisha. Hello Gautam. Thank you. WP is already trending in the chat box. Hello Janice. Good evening. I hope you all had a great New Year celebration and are ready to celebrate the next New Year in AIMS or in a government medical college. And if you're ready, let's begin. Okay. So let's start. Let's start with the lecture. Okay. So remember, we talked about refraction last lecture. We talked about refractive index. We talked about how speed of light changes and how you use Snell's law in different cases. Now, see, my dear students, okay, let me just add a slide here. When you have a plane surface, you draw a normal to it. And then you show that yes, there was a ray which was incident making some angle, and then it refracts making some angle r, and then you used to say sine of I divided by sine of r is 1 mu 2, which is nothing but your relative refractive index, right? Now this is for a plane surface. But what happens when your surface is curved? There could be many examples of curved surface refraction. First, let me tell you the examples and the application. Then we can go to the ray diagram and other formulas. Imagine there is a test tube like this. And if you have seen, if you pour some water in the test tube, the surface of the water is somewhat like this. This is the curved surface meniscus. Some of you in the 11th standard would have studied this part in surface tension, angle of contact, why is it concave up, and all of that. How many of you know this by pure observation? Take some water in the test tube, you see the surface is curved. The curved surface is called as the meniscus of the liquid. It is curved in nature. The concave part is upwards. How many of you know this? Hello Sarat, good evening. Hello Sehna, good evening, my dear warriors. Yes. And imagine that over here, somewhere over here, there is some object. Imagine there is some object over here maybe the image might be formed here or here, who knows. I'm just saying, maybe the image is formed over here. If you notice, this is a curved surface refraction. If the observer is seeing from here, obviously the rays, by the time they reach the eye, they are getting refracted at the curved surface. Also, you might have seen a glass ball or a glass piece or some fossil which is preserved in a glass piece, and let's say that glass piece is curved in nature, it's spherical in nature. Okay, so this could be made of glass or amber. Amber is also kind of a transparent material, and let's say there is some fossil, there is some insect, there is some object, there is some particle trapped here. This is where the object is. Maybe the image might seem here when you observe from outside. Here, the rays, by the time they reach outside, they are getting refracted on the curved surface. They are getting refracted on the curved surface. Vanakkam Ramesh Yogi. Hello Gautam. Get everyone on the chats. Make sure everybody is attending the lecture. Wake up everyone. Tell them that Shreyas Sir has started the ray optics lecture number 2. Yep. So you will see that there are many examples. In fact, lens is also an example. This is a lens. This is nothing but a lens. And if you are observing something through a lens, maybe the image might be formed over here as you see the object through the lens. The rays are getting refracted through the curved surface. Thank you Ramesh for all the love from Tamil Nadu, and I think you are using yellow color to in support of CSK and MS Dhoni. Right. Okay. So now if you have a curved surface like this, and if you draw a normal at any particular place, you will see that the ray of light which might come from outside making some angle I will have some angle of refraction R. This is incident, this is refracted. And you can have many more such rays. You can have many more such rays. Maybe some other ray is probably coming over here. Maybe some other ray is probably coming over here. Okay. And you can draw a normal at that particular place. Maybe that is that angle of incidence, and maybe this is that angle of refraction, and maybe the rays might converge at a point and finally make an image. Who knows? But the point is that the refraction occurs at every single point with a particular normal drawn at that particular place. Normal should be shown at that particular place. So I can say Snell's law is obeyed for all the rays refracting across the curved surface, and at every single point I can say sine of I by sine of R is 1 mu 2, which is also mu 2 by mu 1. At every single place I can say this. And using these ray diagrams, I can finally figure out where the image lies. Using these rays, I can finally figure out where the image lies. Say for example, there is a curved surface like this. There is a curved surface like this. Let's say this is a dense medium. Let's say this is a dense medium on this side, and let's say this is a rare medium on this particular side. Okay, and then what I do is I draw the exact midline which cuts that surface into two equal parts. That will be my principal axis. This will be my pole, right? That will be the pole. Everybody with me? Good evening everyone. That would be the pole. Perfect. And then what I will do is I will draw an object. Let's say for example it is over here. Let's say this is an object right over here. This is an object. And now I want to find where the image is. Maybe the observer is here or here, doesn't matter, but the point is that I want to see where the image is formed right now. So I will show few of the rays, and the rays might look something like this. Observe. One ray might just go like this. One ray might just go like this. As it hits this curved surface, it will get refracted. So to find how it gets refracted, I need to show the normal, and for that I need to also show probably the center of curvature. Maybe it looks something like this. Does it look little realistic? Yeah, I think so. The center of curvature, the radius of curvature. Yes, definitely center of curvature. This is the radius of curvature. Only then this will become the normal. This will become the normal, and this will become nothing but the angle of incidence. This will become nothing but the angle of incidence. Now that ray will obviously get refracted, maybe because this is dense and it is rare, so it will bend away from the normal. So it will definitely bend away from the normal, correct? It should bend away from the normal, maybe like this, who knows? So our ray, which was going like this, has gone away from the normal, something like that. But one ray is never sufficient to make an image. You need one more ray to make the image. So how about showing a ray which directly goes through the center of curvature, something like this. The reason why I showed that ray is because that particular ray will go undeviated, because it will be normally incident. So when it is normally incident, then the angle of incidence is 0. Angle of refraction is also 0. So it will go undeviated. So this ray is going nothing but undeviated. The reason being I is 0 and so is R0. Is that making sense? How many of you got this? Is that making sense? Everybody with me? Hello, good evening, Teju. Awesome. So now, don't you see these rays are diverging in nature? Don't you see this ray and this ray are diverging? That means they will never meet. But to make an image, you should make them meet. Fine, if they are not meeting ahead, no problem. You extend them backwards. And most probably they extend somewhere over here like this. So hence I will say this is the place where my image is formed. Now think about this, my dear students. If the observer is over here, this is the object, this is the image. What kind of image do you think it is by this ray diagram? All I have done over here is ray tracing geometrically. That's all. This is purely geometrical method. You need to use scale, compass, whatever to use this method. Without that, it will be not that accurate. So think about it. What kind of image it is in this particular scenario? I think it is erect. It is also diminished in nature. Whether it is real or whether it is virtual. Come on, let's see if you guys can get this. Are the rays actually meeting? No, right? You have to extend it backwards to make them meet. That means it is virtual in nature. You don't need a screen. You can see it through your naked eye. If that object is placed there, you will see the image is small. You will see it at a different place and it will be erect. Yes, it is diminished. Definitely. No, it is not real. It is virtual. So if I place the object somewhere else, again you will draw the ray diagram. Again you can find the image. Do you have to by heart this? No, you don't have to by heart this. This is just to show how you can find the image using ray tracing, nothing more. But in the examination, you will not have many problems like this. You will mainly be using a formula method. Like in mirrors, you use 1 by u plus 1 by v is equal to 1 by f. That's how you found the images. Same way, over here also, there is a formula. So what's the formula? Let's have a look. If this is the curved surface, and let's say this is the principal axis, and let's say our object is here. Let's say our object is over here. This is our object. And let's say maybe the image is formed right over here. The image is formed right over here. You obviously have the image distance. You obviously have the object distance. The object distance. And remember, everything has to be measured from the pole. Then you also have the radius of curvature and the center of curvature and all those things. So this is the center of curvature. This is the radius of curvature. If you see the rays which are coming out from the object, they are going like this. They are basically going like this. The rays are going in this particular direction. So my dear students, if the rays are going like this towards the right side, that means this side will be positive, this side will be negative. That's the rule of sign convention. Wherever the incident rays go, that side is positive, the other side becomes negative. So quickly think and tell me, is the object distance positive or negative? In the chat box. Is the object distance positive or negative? No, Janice, that's not the formula now. We'll see. The formula is slightly different. Yep. Satya, no issues. Join in, my dear students. What do you think is the object distance, my dear students? What do you think is the object distance, my dear students? Yes, it is going to be negative because this side is positive, this side is negative. Correct. And what about the image distance? It's on the positive coordinate, so it is positive, image 1. And radius, for that, see where the center is. Center is on the positive side, hence that is also positive. Yes. So U is negative because it is on the left side, because rays are going that way. So this is positive side, this is negative side. So U is negative, V is positive, radius is also positive because center is on the positive side of the pole. Is on the positive side of the pole. Is everybody clear till this point, my dear students? Okay, great. So now, wherever the incident rays, see where the incident rays, here, that place, that region will have some refractive index. I will call it mu1. And after getting refracted, it will be in a medium whose refractive index is mu2. So what is mu1 and what is mu2? Mu1 is the refractive index of the medium where incident ray is present. Where incident ray is present. This is very, very important. It is not object which is present, but the incident ray which is present. And mu2 is the refractive index of the medium where who is present? Where refracted ray is present. Where refracted ray is going to be present. I hope this nomenclature is very, very clear. Then the formula looks something like this. Observe it carefully. It is mu2 by V. Mu2 by V minus mu1 by U. Minus mu1 by U is equal to whatever you wrote first and then next. Same order you follow. Mu2 minus mu1. Mu2 minus mu1, but that is a common denominator. And in the bottom, you put the radius of curvature. So this becomes your formula for finding where the image is. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by the radius of curvature. It's a sign sensitive equation. Not just that, you should also know the magnification formula, which is image height by the object height, which is your magnification, which is lateral. Here you just need to know one formula for magnification, not the longitudinal one. That is, look over here, usually for mirrors it used to be minus V by U. That minus sign is no longer there. It will be V by U, but there is more term. With V you have mu2, so put V by mu2, and with U you have mu1, so U by mu1. So that is the complete formula. I have just taught you a trick to remember it by comparing it with mirror formula. What was mirror formula? Minus v by u. So forget the minus sign, v by u, you first write it down. Then with v, you have mu2. So v divided by mu2. With u, you have mu1. So u divided by mu1. So that becomes your formula for your image height by object height. Keep that in mind. Is this clear, my dear students? Is everybody understanding this till this point? Clear? Shall we move ahead? Awesome. Awesome. Great. Cool. So I think we can start solving some questions based out of this. Here comes the first question. A ray of light falls on the surface of a spherical glass paperweight making an angle alpha with the normal, refracted by the medium at an angle beta. The angle of deviation of the emergent ray from the direction of the incident ray is how much? The angle of deviation. Okay. So for that, let me first draw a sphere. Okay. Let me also show some normal. Okay. So imagine there is a ray which enters in over here. This ray has, entered in over here, and it is making some angle alpha. It is making some angle alpha over here. And what happens is it gets deviated like this. It gets refracted inside. So it goes inside like this. So I'm just showing this again. Just showing this normal properly, nothing more. Okay. Same thing over here. Yeah. And then again, after coming over here, it gets refracted. Again, it gets refracted right over here. This is how the ray travels. This is how the ray travels. Observe now carefully. It is incident at an angle alpha with the normal. Angle alpha with the normal, refracted in the medium at an angle beta. That means this angle is beta. This angle is beta. Question is, find the total deviation of the emergent ray. This is your emergent ray. This is your emergent ray. And this is your initial incident ray. Now the logic for this kind of question is, if you just take in general any refraction, draw a normal and show the incident and then the refracted ray, how much does it deviate by? How much does it deviate by? This is your delta. Can you guess what is the deviation? The incident ray was going in a peculiar direction. It got tilted by some angle. What do you think is that angle by which it is tilted? Hello Sensei, thank you so much for the love. Guess it. It's not that difficult. If this is I, this would have been I. This whole thing would have been I. Correct? Opposite angles. This and this. If this is I, this would be I. Correct? Correct? So out of this I, you take out this R. How much is remaining? How much is remaining? That is basically your deviation. I minus R. But sometimes I is more, sometimes R is more, depending on the medium. So generally you put a mod symbol because I don't know who is more. Depends from, yes, it is not 2I minus E, it is just I minus R. So this is a very interesting thing which I got by looking at this simple diagram. So if this is clear, then we will proceed ahead. If this is clear, let's proceed ahead. Everybody got it till this point? Give me a thumbs up. So this I and this I are same. Out of that, R is taken out. So I minus R is I minus R. That's the angle by which you have deviated. So over here, observe carefully, the ray deviates once and again once more. So there are two deviations happening. So the total deviation is delta 1 plus delta 2. Delta 1 plus delta 2. Now, in this particular diagram, do you see if this is beta, if this is particularly beta, then even this would be beta. Why? Because it is an isosceles triangle. This is an isosceles triangle because both of them are radius r and r. So this triangle is isosceles. So the base angles will be equal. The base angles will be equal. Also, by reversibility principle of light, if light goes in at alpha and comes out at beta, then if it goes in at beta, then it will come out at alpha in the air medium. Won't I use the reversibility principle? Everybody getting it? So alpha to beta, beta to obviously this is going to be alpha. Oh, so now I got to know all the angle of incidence, angle of refraction, angle of incidence, angle of refraction. So when I write delta 1 and delta 2, what will the values be? Delta 1, bigger angle minus smaller angle. Remember, delta is always made positive. Hence, you use the modulus. Hence, you use the modulus symbol. So, alpha is bigger or beta is bigger? Obviously, alpha is bigger. That's the first deviation. Plus, who is bigger, alpha or beta? Obviously, alpha. So, alpha minus beta. So, hence, it will be 2 times of alpha minus beta. A beautiful question on curved surface refraction. Oh my God. Please, please, please don't use. Oh my God. The Siri gets activated from my phone at random times. Yes. So angle is 2 alpha minus beta. Did you love this question? What were the key takeaways? First key takeaway was, in case of refraction, the angle of deviation is not 180 minus 2i. That is only for a mirror. For a refracting surface, it is I minus r's modulus. Second thing is we had to use some geometry. Like this is isosceles triangle, angles are equal and all of that. Third thing, we use the reversibility principle. If this is alpha, this is beta in glass. So if in glass this is beta, in air it should come back to alpha. And the last thing, the total deviation will be deviation in the first one plus the deviation in the second one. That's the total deviation. By formula I got it. Right? Reversibility principle, Janice, is if light enters from air at some angle and goes in some medium at some beta angle, then if light is incident in the glass or that medium at beta, then again when it comes back in air, it will come out at alpha angle. Okay? Air, medium, alpha, beta, medium, air, beta, alpha. Reversibility principle. Just flip it. Got it? Shahin, you can still catch up, bacha. You can still catch up. Don't worry. All right. Let's go to the next one. There is a equiconvex glass lens with the radius of each face r, this. And okay. If there is water in the object space and air in the image space, then the focal length is. Beautiful question. Let's have a look at it. Okay. Now, in order to understand this question, let's go behind and let's just take up a simple example and see if you guys are able to at least put up things properly in the formula. Imagine if this is at a distance of 20 centimeter and let's say this is 10 centimeter. Let's say this is having a refractive index of 2. This is having a refractive index of 1.5. And this is your object and I don't know where the image is. If I have to solve this problem and to find where the image is, I want to find where the image is. So if when I use the formula mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. First of all, decide who is positive, who is negative. This is the object, so the rays will go like this. Rays are going like that. This is the pole. That means this is the positive side. This is the negative side. You can see the object is on the negative side. Center of curvature is on the negative side. So let's start putting up all the values which we can find out. First of all, object distance. Object distance will be negative 20 because it is on the negative side. So this I will put it as minus 20 object distance. Next, radius of curvature. For that, look where the center is. Center is on the negative side. So it will be nothing but minus 10. Then V value I do not know. So I'll just leave it as it is. In fact, we have to find that out. Yes. Kept over deviation is 180 minus 2i, y, I minus r. Sheena, you got confused. I'll come back to it. Hold on. Just one second. Just one second. In this, who is mu2, who is mu1? Who is mu2, who is mu1? Just answer that. Then, Shena, I will definitely answer your question too. Tell me, my dear students, who do you think is mu2, who do you think is mu1? I feel that if you go back and read my theory carefully, you will realize mu1 is where incident is, mu2 is where refracted is. Where is the incident ray? Incident ray is in this medium, so this 2 is mu1. So this is basically 2. This is basically 2. Is that making sense? Mu2 is where the refracted rays, so these rays will get refracted in that medium. So this is mu2. So this is 1.5 and this is also 1.5. Is this clear? And then solving this, you can find the value of V. So this is your homework. Please try to solve this as homework. This is just a basic problem to tell you how to get image distance for curved surface refraction. You can post the answers in the comments and you can also debate, or you can post it on my Telegram channel, which is Captain Shreyas. There is a group for all of you to discuss. Yes, 1.5 is mu2, very good, and mu1 is 2. So if this much is understood, let me also explain this to you in this particular problem. Where we spoke about deviation. When light comes here and gets reflected, this is reflection. This is reflection. This is your normal. This is your eye. This is also your eye. Then the deviation is 180 minus 2i. That is for reflection. But when you have refraction, this is I, this is your R, the deviation is I minus R, whichever is bigger. So that's my modulus. This is for refraction. Totally two different things. So please don't by heart just a formula without knowing where to use it. You should always remember where to use it. Remembering formulas will not give you marks in NEET physics, because many students ask me that, and you know the problem is in many coachings they tell just remember the formulas, it is more than enough for you to get 120, 140 marks. You can try it out. You can just try solving previous year papers in a proper exam environment and you will see you will not be able to get even 120 marks just remembering the formulas. So that's why know where to use it, when to use it, when not to use it. This is for reflection, this is for refraction. So I hope the doubt is clear. That is very important. And that's why students come over here, because any silly doubt also you ask, I will make sure that the concept is registered in your head. Is that clear? Yes. Okay. Yes. Cool. Cool. Shall we proceed ahead? Shall we proceed ahead? You will be able to do this homework. Everybody is going to post the answers in the comment section. Everybody is going to post the answers because I have done everything till here. You just have to calculate or move around things and you will be able to solve and get the answer. Okay, that is something which I am leaving it up to you. So let us do a little bit much better question than that, and here it is. You can see an equiconvex glass lens with some radius is there, and the question is what is the focal length. Okay, so for that let us just draw an equiconvex lens. Let us also show the principal axis. Okay. Now, when we try to find the focal length of anything, where is the object placed? You take the focal length of a concave mirror or convex mirror, convex lens, concave lens, whatever. You want to find the focal length. Where do you place the object? The object is at infinity. The rays are parallel. And where do they focus? A faraway object from which the rays almost are parallel, where do they eventually meet? So, can I then say that here in this particular scenario, the rays which are coming from the object are almost parallel to each other? So I can just say it is, basically parallel like this, and it gets refracted here, and it gets refracted here, and maybe it goes like this. Maybe it wants to go till here. Maybe it wants to go till here. But before it reaches there, I think it gets refracted once more, and maybe it comes over here. Maybe it comes over here. Okay. So Just 1 second. See if you have understood this ray diagram. See if you have understood this ray diagram. The rays are coming from infinity. It is a parallel beam of light. Then it gets refracted for the very first time. It will try to come over here, but there is another surface over here, because of which it gets refracted again and finally meets over here. So this is where your focus is. This is where your focus is. Everybody clear? Everybody clear till this point? Awesome, awesome, awesome. Now I feel there are two surfaces. There are two surfaces, so we will have to use the formula 2 times. How many of you understood that? By looking at the problem that, sir, there are two surfaces, it's a lens. So that's the reason why I'll have to use the formula also 2 times. And notice that the water, that there is water in the object space. That there is water in the object space. That means this is where the object is, this is where the water is. So this side has water placed. So that water has a refractive index of 4/3. So this is having a refractive index of 4/3. Then the glass has a refractive index of 3/2. This is having a refractive index of 3/2. And this is air. So this has a refractive index of 1 because this is air. This was water. This was water. Everybody fine till this point? Everybody fine till this point? Cool. So let's apply the curved surface refraction formula for this first surface. And for that, when I choose this as my first surface, I need to see where the center of curvature is. The center of curvature for the first surface will come somewhere over here. You can see that. This will be the radius. So maybe the center of curvature is here, C1. Because the rays are going like this, because the rays are going towards the right side, won't this side be positive? Won't this side be negative? Won't that side be positive? This side be negative? Okay. So let's use the formula. What is our formula? Mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. So for the first time when I use it, mu2, what do you think mu2 will be? Where is the refracted ray? This is the refracted ray. Which medium it is in? 3/2. So this is 3/2 by V minus mu1, where the incident rays in water whose refractive index is 4/3. Where is it coming from? Infinity. So this will be just infinity. Don't put anything else. Clear? Great. Is equal to mu2 minus mu1. So 3/2 minus 4/3 divided by radius. What is the radius? I think that was also given to us. What is the radius? I think we have to give it in terms of R. Will I use plus R or minus R? C1 is on the positive side. So yes, it should be plus R. So it should be plus R. What is any number divided by an infinitely large number? When you divide it by a big number, the number becomes 0 because denominator is huge. So ignore this part. It has just become 0. So this will become 3/2V minus 0 is equal to 3/2 minus 4/3. What will this be? LCM is 6. 3 3s are 9. 9 minus 8. So it will become 9 minus 8 divided by nothing but 6R. So you will see that this 2 and this 6 cancels, becomes 3. This will just become 1. So basically your V will just become 9R. Just check this out. Has V become 9R? Everybody with me? Has V become 9R? Everybody with me? What does it mean? What does it mean? It just means that this distance which is there, that is basically 9R. That is basically 9R here. This distance is 9R. That's where the image is formed. Now please understand, this image which you see is actually going to be the object for the next surface. I had told you this in the previous lecture. Whenever there are multiple events happening, multiple refractions, reflections happening, then the image of the first becomes the object for the next. So if the image is formed at 9R, for the next surface, this is the object, and then your final image is formed over here. Final image is formed over here. Is that right? Everybody with me? Is that very, very clear? Is that very, very clear? So let's try to solve it for this part, that is for the second surface. For this surface, the center of curvature is here, that is C2. The center of curvature is here, that is basically C2. Very good. Now, what do I do? Okay, let's use this same formula and see what do we get. What do we get? Okay, observe carefully now. For this surface, this is the incident ray and this is the green one is the refracted ray. So mu2 is where the refracted ray is, it is in air. So that is going to be 1 by V, I don't know where V is, okay, minus mu1 is where the incident ray is, it is in the glass, which is 3 by 2, divided by object distance. The object is on the positive side and that is at 9R distance, because the image is now the object. So 9R is equal to mu2 minus mu1, so 1 minus 3 by 2, divided by C2 is on the negative side. C2 is on the negative side, so the radius of curvature will be minus R. Radius of curvature will be minus R. So now you just have to solve this. So 1 by V, and this 3 by 2, and 3 and 9 will cancel. So it will become 1 by 3 and 3 2s are 6. So minus 6 by R will be equal to 1 minus 3 by 2 is minus 1 by 2, minus minus cancels. So it will become 1 by 2R. So therefore 1 by V is equal to, take it on the other side, 1 by 6R plus 1 by 2R. Is that right, everybody? 1 by 6R plus 1 by 2R. Solve this further, it's not that a big deal. So 1 by V will be, take LCM, 6 and 2R, the LCM is basically 6R. So it will be 1 plus 3, which will be 4 by 6R, which is nothing but 2 by 3R, that is 1 by V. So V will be 3R by 2. That's where the final image will be formed. That means this distance we got it as 3R by 2, but this is exactly the point where the rays meet. So that is the focal point, hence the focal length is 3R by 2. Hence the focal length is 3R by 2. So we had to use curved surface refraction formula 2 times. This is the most complex question that you can get in NEET level. That too very rare chance, but if you get it, this is how you do it. Once you understand this question, you cannot make it wrong. You cannot go wrong with other things. All right. So I hope everybody has finally understood how to use this formula, how the sign convention works, how your radius of curvature is taken and other things. Cool. Shall we go ahead with the next part? And that is basically, I think, lenses. Everybody ready for this? Cool. Yes, it is ready. Definitely lengthy to solve in 1 minute. So how many of you think that all the problems will take 1 minute in the examination? If you think so, that is wrong. Not all problems will take 1 minute. Some problems will take you 20 seconds to solve. Some problems will take you 3 to 5 minutes also to solve. Please bear that in mind. Don't think that all the problems take 1 minute. That's a common misconception. You have to average it out to 1 minute to 2 minutes. And I'm telling you, for NEET physics, even if your average is above 1 minute, it is okay. But somewhere between 1 minute to 1.5 minutes, generally that's where the average comes. Even if it is 1.5 minutes, you can still score above 170 marks. Yes, you can still score above 170 marks by solving those 45 questions, because usually you make up time in biology and chemistry. Keep that in mind. So don't worry about timing being more than 1 minute. It's perfectly okay. Only some questions can be solved below 1 minute. Many questions might take even more than 2-3 minutes. That's okay. Now talking about lenses. Talking about lenses. Okay. So, be it your camera, be it your mobile phone, be it a magnifying glass, be it a telescope, be it a microscope, everything has lenses in it. And there are different kinds of lenses. What is the name of this lens? Come on, put it up in the chat box. What is the name of this lens? Put it up in the chat box. Also, what is the name of this lens? Put it up in the chat box. Also, put what is the name of this lens in the chat box. Also, put what is the name of this lens in the chat box. Come on, if you know this, put it up. Start putting it up in the chat box, everybody, one by one. What is this? This is nothing but a convex. This is a simple convex lens. This is nothing but a simple concave lens. This is nothing but a plano convex lens. This is nothing but a plano concave lens. This is convex on one side, concave on the other side. So you can say concavo convex lens. So that's just the name given to it. Just the name given to it. That's all. Now, in convex lens also or in concave lens also, sometimes you might see one surface is like this, one surface is like this. But sometimes you might say both the surfaces are equal. Here also, sometimes one surface is like this, one surface is like this. Sometimes you see the surfaces are both equal on both sides. This is a simple concave lens. This is a simple convex lens. But here, when both sides have the same radius, same curvature, same shape, you can see it is symmetrical, then it is called as a equiconvex lens. Equiconvex. And this is called as a equiconcave lens. Equiconcave lens. Is that clear, everyone? Yes. Handpicked, I think you can get my lectures in the VBuddy, which is a part of the Pro subscription. So once you take the Pro subscription, there is a batch which you can access where all my recorded classes are also there. So you can, through the VBuddy program, access those things. Yep, cool. Now, if this thing is clear for everyone, any kind of lens will also have a focal length, and only when I know the focal length, I can find where the image is formed. How to find the focal length? I think we just did a problem and that was very lengthy, right? But what if I told you that there is a formula by which you can find the focal length and you can directly use it in your problems. But it only works if on both sides you have the same medium, air, air, water, water, glass, glass, amber, amber, gas, gas, medium, medium. Only then. But this is water, air, air, water, glass, amber. No, it won't work. So that's the reason why we had to go via this lengthy method in this problem. But when the medium is same on both sides, then you can definitely use a formula. So observe this carefully. If I have a lens like this, it could be convex, concave, doesn't matter. And let's say this is the principal axis, and let's say this is the center of curvature, this is the center of curvature, C1 and C2. How did I get C1 and C2? This is your radius of curvature 1. This is your second radius of curvature. How do I know which is R1, which is R2? It doesn't matter. Whether you hold the lens like this or you hold the lens like this, the focal length does not change. So it's okay whether it is concave or convex or plano concave, concavo convex, plano convex, doesn't matter how you hold the lens, like this or like this, which surface comes first, which surface comes next, the focal length remains the same. The focal length remains the same. And these lenses are specifically thin lenses. We do not study thick lenses in NEET, don't worry. For JEE Advanced it might come, but for NEET and even JEE Mains it doesn't come. So thin lenses meaning the surfaces are very close to each other. It's a very thin lens. So in such kind of scenario, if a parallel beam of light comes, we know that it will probably focus at a point or will try to move away from a point. There will be a focal length associated. That 1 by f is given by the refractive index of the lens with respect to the outside medium minus 1 the whole thing into 1 by R1 minus 1 by R2. For R1 and R2, you have to stick to the sign convention. You have to use the sign convention. And remember power formula. How many of you remember power? Power in a mirror. In ray optics 1, I have taught you that. Power is how much you converge or diverge. For a mirror, what was the formula? It was negative 1 by f. In lens, it is positive 1 by f. As simple as that. So for lens, it is positive 1 by f. So power is just 1 by f, is refractive index minus 1, 1 by R1 minus 1 by R2. So this becomes a big formula which you must remember. And what is it called as such? This is only called as the lens maker formula. Lens maker formula. Very, very important. P is power, which is expressed as diopters. P is basically the power, which is in diopters. If focal length is in meters, If you take a normal convex lens versus a concave lens, you will see in convex lens the rays meet over here. In case of concave lens, the rays appear to diverge from a point and you will have to extend it behind. This is where you get the focal length. So in the case of convex lens, you will see that the focal length is a positive number, because this side is positive, this side is negative. The rays are going that side, so this side will be positive side, this side will be negative side. Whereas in the case of concave, you will see that the focal length is negative. Whereas when we talk about the power is 1 by f. If f is positive, even the power is going to be positive. And here the power will be negative. And it kind of makes sense because this is converging. For converging, the power is positive. And when it is diverging, then the power is negative. So it all falls into place. It is, definitely making sense. These were the things which I told you in the previous lecture. Everyone with me? So, trying to, summarize this slide. If you have a lens and you want to find where the image is, the first thing that will come in your mind is you need to know the focal length. If focal length is given, good. It is not given, you will be given the refractive index of the glass, refractive index of the outside medium, if it's dipped in some liquid, else it will be just air, so it is just 1. Then the rays will meet at a point. That's how you know that that is the focal length. So the formula for focal length is 1 by f is also the power, which is mu minus 1, 1 by R1 minus 1 by R2. What is R1, R2? This is the first surface, this is the radius, this is the center. So R1 is the radius of curvature of the first surface. For the second surface, this is the radius, that R2 will come here. I will show you, I will demonstrate this to you by example. But for now, just understand this is the formula for the lens. Be it concave, be it convex, it has two surfaces. That's why you have R1 and R2. Okay. What is this term? This is the relative refractive index. Please remember that. So refractive index of the lens with respect to the medium. So it is actually mu L divided by mu M. So it is the refractive index of the lens with respect to the medium outside. With respect to the medium which is present outside. Is that okay? Till this point, if it is clear, issue? Can we go ahead then? Can we go ahead? Okay, let me demonstrate to you as some simple examples. Imagine this. There is a convex lens. Okay, there is a convex lens. This is, let's say 10. Let's say this is 20. And the question is find the focal length. Question is find the focal length, and it is given the refractive index over here is 3/2. Refractive index over here given is 3/2. Let's try to find the focal length using lens maker formula. What is the lens maker formula? Mu minus 1 by R1 minus 1 by R2. Here outside medium is air. When you talk about air, the refractive index is 1. So what will be the relative refractive index? What will be the relative refractive index? It's the absolute one only. So can I just put it as 3/2? Can I just put it as 3/2, my dear students? Okay, great. Now I'll just put minus 1 over here. Now here I'll put 1 by R1 minus 1 by R2. What is R1? Well, if the rays of light are coming like this, if the rays of light are coming like this is the first surface where the surface refracts. So hence this will be C1, and after going through this surface, it cuts through this curved surface. So for this curved surface, this will be the center and this will be the radius. So because we assume the rays of light going like that, so this is on the positive side, this is on the negative side. So now think and tell me, is the radius of curvature 1, isn't it not plus 10 because it is on the positive side? So won't I put plus 10 over here? What about R2? R2 is on the negative side because C2 is on the negative side, and won't it be minus 20? Won't it be minus 20, my dear warriors? Everybody clear till this point? Okay, so what will this be equal to? 3/2 minus 1 is 1/2. Then this will become minus minus is plus. Minus minus is plus. So 1/10 plus 1/20. LCM is 20. So it will become 2 plus 1/20. This will become 3/40. So therefore, F will become 40/3 centimeters. 40/3 centimeters. Got it? Yes, black caps, you can watch this, no issues. Some of you will be thinking, sir, what if for the same lens, okay, for the same lens, this was 10, this was whatever, 20. Somebody decided to take the rays of light coming this way. Will the answer change? Let's try out. Let's try out. Basically, I'm changing the lens's side. That's all. I'm inverting the lens. Let's find out. So if this is the incident side, so the rays are going this way. So now this will become positive. This will become negative. Correct? Because this is the first surface. This will become C1. And after that they enter this surface. So yeah, my bad. I did it wrong. The rays of light hit this surface first. So for that surface, the radius is this one. So hence this is center of curvature 1. After cutting through this surface, it cuts through this surface. So for that radius, this is the second radius of curvature. So let's use the same formula and see what do you get. 1 by F is equal to refractive index of the glass with respect to outside medium is 3/2 minus 1. 3/2 minus 1. Okay. So that is the first part of that lens maker formula. 1 by R1 minus 1 by R2. 1 by R1 minus 1 by R2. What is R1? What is R1? Look at it. C1 is here. It's on the positive side. So it will be 1/20. What is R2? That is 10, but it is on the negative side. So minus 10. 3/2 minus 1 is basically half. And 1/20 minus 1/20. Sorry, minus 1 by minus of 1/10. So it will be 1 by plus 10. Minus will cancel. So it will become 1/20 and 1 plus 2. Oh, this is coming out to be 1/2 into 3/20, which is again 3/40. So again, I will get the same answer, 40/3. So what does this tell you? The answer will come out to be the same. It doesn't matter whether you hold the lens like this or you hold the lens the other way around. I can show you one more example. Let's say, for example, our lens is a plano-concave lens. A plano-concave lens, refractive index is 2. Refractive index is 2. And let's say the radius is, I don't know, maybe 40 centimeters. Example. Question is to find the focal length. Question is to find the focal length. So let's start solving the question. You can take the rays coming from here or coming from the other side. It really doesn't matter. Let's say the rays are coming like this. The rays are coming like this. This is the incident ray. So this side will be negative. It is going towards that side. So this side will be positive. This is the first surface. This is the second surface. This is the second radius. So this is C2. Where do you think is C1? This is the first surface. So for the flat surface, where do you think the center of curvature will be? I'll give you a hint. I'll give you a hint. Come on, think about it. If the surface was like this, center will be here. If the surface is like this, the center will be here because now the radius has become larger. If the surface becomes like this, then the radius will become even more, correct? And the moment it becomes flat, what will happen to the radius of curvature? Won't it become infinity? Won't it become infinity? Exactly, very good, Shatika. If the lens is concave, f will become negative. We'll see that, Shabin. We'll see that. This is a concave lens. Let's see whether the focal length comes out to be negative or positive. Now, for this particular problem, if I use 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2, what will I write? 1 by f is equal to, observe, what is the value of mu? Well, it is 2. So 2 minus 1. Okay, 2 minus 1. Okay, 1 by r1 minus 1 by r2. What is r1? That is the first surface. It's a flat surface. So for a flat surface, radius of curvature is infinity. So I'll just put r1 as infinity. For a plano surfaces, you will always see radius will be infinity, at least on one part. Correct. Now for the second part, this part, the second radius is on the positive side, so it should be positive 40. So 2 minus 1 is 1. 1 by infinity is 0. So minus 1 by 40. So won't this become minus 1 by 40 is 1 by f? So won't f become minus 40 centimeters? Won't f become minus 40 centimeters? Everybody got this? F is coming out to be negative. That means, you know, it is a diverging kind of a lens. F is negative. That means the focal length is on this side. So it is diverging kind of a lens. Correcto. Very nice. Very nice. Okay, so I think now it's a good time that we solve one more question and then go to the objective questions. Observe this question. Observe this question. This is a concave lens. The refractive index is 3 by 2. It is placed in some medium. It is placed in some medium whose refractive index is 2. Whose refractive index is 2. It's a equi-concave lens of radii equal to 10 centimeter. Question is find the power of the lens. Question is find the power of the lens. So to find power, what do I need? Focal length. To find focal length, what do I need? Lens maker formula. So let's start with the lens maker formula, which is refractive index of the lens with respect to the medium minus 1 by r1 minus 1 by r2. Do not forget, this is actually mu L divided by mu M. So therefore, 1 by f will be, lens's refractive index is 3 by 2. So this will be 3 by 2 by medium's refractive index is 2. So I'll just put 2 over here. Minus 1 by r1 minus 1 by r2. Okay, observe now carefully, my dear students. If the rays of light come from this side will be positive, this side will be negative. This is the first surface, this is the first radius. So center of curvature 1 is here. After that, this will be the next surface, this will be the next radius, this will be the next curvature C2. This will be the next curvature C2. Yes or no, my dear warriors? Perfect. Now tell me clearly, my dear students, what is C1, what is C2? C1 is on the negative side, so R1 will be negative and radius was 10. So minus 10. R1 is 10. Correct? Everybody? Next, what about R2? For that, check C2. C2 is on the positive side, so it will be plus 10. So it will be plus 10. Correct? Okay. Now let's try to solve this and see what do we get. 3 by 2 by 2. So it will become 3 by 4. 3 by 4. Correct? 3 by 4 minus 1. 3 by 4 minus 1. And this minus minus comes common. So I'll take that minus sign common over here. And this will become 1 by 10 plus 1 by 10. 3/4 minus 1 is minus 1/4. Is minus 1/4. 1 by 10 plus 1 by 10 is 2 by 10. 2 and 4 cancels. Minus minus also cancels. So I think I'll be left with 1 by 2 over here and 1 by 10 over here, which is nothing but 1 by 20. So what is the focal length? It is basically 20 centimeters or basically 0.2 meters. 20 centimeters or 0.2 meters. Now is the interesting part. The focal length came out to be positive and the lens is concave. Is this okay? Was this okay? It's sounding little bit weird, right? Sir, the lens is concave and how come the focal length came out to be positive, sir? I thought the focal length will be negative because it is diverging. You know why? Because the outside medium is more refractive than the lens's medium. Yes, it is more refractive, denser. That's the reason why you saw that the focal length came out to be positive. So yes, a concave lens can also become converging and a convex lens can also become diverging if it is placed in a medium which is more refractive than the lens's medium itself, just like in this problem, just like in this particular problem. Is that clear, my dear students? Everybody with me? Did you understand this? Everybody? Very good, very good. So finally, what will be the power? Power is 1 by F. So it is 1 by 0.2, always in meters. So that is nothing but 5 diopters. So the power is nothing but 5 diopters. That is the final answer, because that was the question. What is the power of the lens? Is that okay? Shall we move ahead? Clear or shine? Very good. Yes, Alekia, answer is 5. Yes, 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 Shatiga. Perfecto. So let's start with some questions coming up on your screen. A substance is behaving as a convex lens in air and concave in water. Then the refractive index is, I think we just did a question like that, and this is completely based on that. If there is an object, optical instrument, which is convex in air, that means it is converging, and concave in water, that means it is diverging. So if it went from converging to diverging, why would that happen? Because the medium outside is more refractive. That means what? It is greater than air, but yeah, it is less than that of water. So the water has more refractive index than that of the glass. This is the medium outside, this is the medium outside, and this is the lens. So medium is more refractive than the lens. So I can say the lens is less refractive than the water. Yep. Answer is C. Correcto. Is that clear, everybody with me? Cool. It is completely based out of this question, which was right over here. That's why you should solve solved questions. Then solving the other questions becomes easy. Sometimes the theory from or the learning from one problem, like over here, is useful for other problem. If you start with this problem from scratch, it is very lengthy. But because you have solved other questions, it becomes easy. That's why solve many questions. Don't just try to read NCERT. It will not be useful. NCERT is must. Textbook is must. But solved examples and practice is also must. Radius of convex surface of a thin plano is 15. Refractive index is 1.6. The power will be, come on my dear students, what is the power? Okay, so it's a plano convex it's a plano-convex lens. So assuming the rays of light are coming like this, where this is positive, this is negative, this is negative. This is the first surface, this is the second surface. So the center of curvature C2 will be here. And for the flat surface, C1 will be at infinity. Do not forget that. So using lens maker formula, mu minus 1 by R1 minus 1 by R2. Refractive index is 1.6, so I'll put 1.6 over here. 1 by R1, the first surface radius will be infinity because it is flat. The second surface C2 is on the negative side, so I'll put a minus sign, and the radius is 15. So this will become 1.6 minus 1, which is 0.6. 0.6 is nothing but 6 by 10. 0.6 is nothing but 6 by 10. 1 by infinity is 0. Minus minus is plus, so it will become 1 by 15, of course. This 6 cancels with this 10, 3, and this is 5. And this 3 cancels with 15, 5 times. So 5 5s are 25, correct? So focal length is 25 centimeters, which is 0.25 meters or 1 by 4 of a meter. That's not the part. You have to find the power. Power is 1 by F. So it is 1 by 1 by 4. So it is 4 diopters. 4 diopters is doctor. D for doctor. D for Ames Delhi. That's the correct one. Very good, Shine. Very good, Alikhya. Awesome. You guys have solved it. Really, really proud of all of you. Really, really proud of all of you. Let's go on to the next one coming up on your screen. Here it is. A double convex lens has a focal length of this much. Radius of curvature of one of the surfaces twice the other. Find the radius of both the surfaces if refractive index of the material of the lens is 1.5. The focal length is already given. Refractive index is given. They are asking you the exact opposite in NEET 2019, that is radius of curvature. Okay, I think we should draw the diagram. That will be always better. So one surface is like this, one surface is like that, and let's say, you know, this is R. So then I will say this is basically 2R, and if the ray of light is coming like this, this will be the positive side, this will be the negative side. Positive side, negative side. R, 2R. Why? Radius of curvature of one surface is twice the radius of the other. Okay, that's the reason. Cool. So with this, so with this, if the ray is coming like this, this is the first surface, this will be the first radius, hence this will be C1. And then this is the next surface, this is the radius of that, so this is the C2 value. So let's use lens maker formula. 1 by F is equal to mu minus 1, 1 by R1 minus 1 by R2. What is the focal length? The focal length is 25. So 1 by 25. What is refractive index? It is 1.5. Okay, so it is 1.5 minus 1. What is R1? R1 is on the positive side because C1 is on the positive side and the value is 2R. So I'll put plus 2R minus 1 by. Radius 2 is C2. C2 is on the negative side, so it will be minus R. So therefore 1 by 25. 1.5 minus 1, 0.5. 0.5 is nothing but 1 by 2. And then this will become minus minus is plus. So 1 by 2R plus 1 by R. So take 2R common. So it will become 1 plus 2 basically. So let's see what happens. So 1 by 25 is equal to, this is 3, 2 2s are 4. So therefore R will become 75 by 4 centimeters. 75 by 4 centimeters will be 18.75. Yes, it will be 18.75, correct. So 18.75 centimeters. So that is R, and that also means 2R. If this is 18.75, you double it, you will get as 37.5. You will get it as 37.5 centimeters. So you found R and 2R both. Straightforward question which was asked in NEET 2019. Did you love this question? Was it not interesting? Thank you, Pandu. Glad Sneha, glad Bhavya, glad to know that I'm making it easy. But I'm surprised why so less students today. What is the reason? New Year party still going on. New Year party hangover still going on. New Year celebrations, holiday vacations still going on. Or just made the resolutions and then, sir, lazy sir. Oh my God, wait sir, we'll start. Or many people, I think they are still in that ray optics 1 mode. Ray optics 1 mode. So I'm wondering where is that remaining 70-80% of the students? I'm seeing 70-80% less students today. So maybe, you know, you need to kick the other students, slap the other students, hit the other students with a scale now so that they will come. So call them up for the next class and tell them to watch Ray Optics 1 and then watch the Ray Optics 2 part. Okay, cool. So let's begin with the next question then. Thank you, Pandu is always there for me. Thank you so much. Okay, next one. What is this? Acha. Okay, now before going to this question, I think we need to go to the next part of the lenses, and that is lens formula. See, I gave you lens maker, which I gave you right over here. Lens maker is a formula which tells you to make a lens of a particular power of focal length, what should be R1, R2 or mu. So to make the lens, to find the focal length or to find the given power. Or if power is given, you can find R like it was in the NEET 2019 question. But when you already know what the power or the focal length is, then you are interested in finding out where the image is formed. So this is some lens, concave, convex, doesn't matter. You have an object over here, and let's say the image is formed right over here. This is image distance, this is object distance, this is object height, this is image height. Then what you get is the lens formula, not the lens maker, it is just the lens formula or the lens formulas. It's not maker, it's just lens. Just like the mirror formula was 1 by V plus 1 by U is 1 by F. In lens formula, it is not plus, it is just minus. So 1 by V minus 1 by U is 1 by F. Instead of that plus, what you get is that minus. That's the major difference. So wherever plus was there, minus will come. If minus was there, plus will come. So say for example, the next formula, which is the image height by the object height. What is the formula? The magnification lateral. It was minus V by U for a mirror, but for a lens, it is plus V by U. It is exactly opposite, nothing different. This is your magnification formula, lateral. Remember this lateral magnification formula. Okay. Thank you, Siva, for sending it. I'm so glad, Sanvi. I'm so glad you're loving it. That's all. See, if you know that, you know this. Sign convention formula is same. Ray tracing, everything same. This was your lateral or perpendicular to principal axis formula. Perpendicular to principal axis formula. The next was width of the image by width of the object. The image will be this wide, the object is this wide. How much did it get pulled along the principal axis? So that is longitudinal magnification. I had explained this to you also. That was minus of V square by U square. Minus will no longer come. It will be just V by U whole square. That's it. And if you remember, over there, I had told you that if the object is moving with VO speed and the image is moving with VI speed, or VOBJ are the velocities, then the ratio of the velocities velocity of the image upon velocity of the object also is the same formula. So it's one single formula only which you need to remember, longitudinal wise. So this was your longitudinal formula, or I can say along or parallel, long. You can see long over here, along the principal axis. So these are the only formulas which you need to know regarding a lens. 1 by V minus 1 by U is 1 by F, same like mirror. Magnification lateral is V by U without the minus sign, and longitudinal magnification, which is also the ratio of the velocities, is V by U whole square. As simple as that. Okay, so let's begin with some questions. Let's begin with some questions now. Let's start. Here's the first one coming up on your screen. Let's see what does it say. There are 2 point light sources which are 24 centimeters apart. Where should a convex lens of focal length 9 centimeters be put in between them from one source so that the images from both the sources are at the same point? Okay, so this is the first question which is coming up on your screen. Let's try to solve this, my dear students. Okay, so although this is going to take a little bit more time, we can do one thing. We can probably look at some easier question first, and then we can come back to this question, because I want you to get some confidence. Okay, let's do this first. Yeah, this might be easier. Then we'll come back. Find the longitudinal magnification of an object of a finite width which is placed at 20 centimeters left of a diverging lens of focal length minus 30 centimeters. Diverging lens, that means like a concave. So focal length is minus 30. Object is placed at 20 centimeters left on the diverging lens. So this is my object. How far it is placed? At a distance of how much? 20 centimeters. Okay, at a distance of 20 centimeters. How will the rays come from the object? They will come like this. So that means this is the positive side, this is the negative side. This is the positive side, this is the negative side. In order to find longitudinal magnification, I need V as well as U. I know U, but I don't know V. To find V, I need lens formula. To find V, which is image distance, what do I need? I need the lens formula. Thank you, Fani Sairam. Thank you so much. Thank you. Let's use 1 by V minus 1 by U is 1 by F. So 1 by V minus U. Oh, is the object distance 20? No, it is on the negative side. So if it is on the negative side, what will you do? You will put minus 20 is equal to, focal length is already given to be negative, so minus 30. So therefore 1 by V minus is plus. Take it on the other side, again becomes minus only. So it will become minus 1 by 20. Take minus sign common. 30 and 20 LCM is 60. 30 goes with 60 2 times. 20 goes with 60 3 times. So 2 plus 3. So it will be minus 5 by 60, which is minus 1 by 12. But remember, that is 1 by V. So therefore V will be inverse of that. So it will be minus 12 centimeters. It will be minus 12 centimeters. Everybody with me? Cool? Clear till this point? Minus 12 centimeters. That's not the question. The question is longitudinal magnification. And the formula for that is V by U whole square. What is V? V is minus 12. This is minus 12. What is U? U is minus 20. This is nothing but minus 20. I have to square this. Minus will not matter at all. 12 and 20 divisible by 4. So it will be nothing but 3 by, divisible by 4 3 times, divisible by 4 5 times, 3 by 5 whole square. So that will be 9 by 25. That will be 9 by 25. What is 9 by 25? Come on, do the math. It should come out to be 0.36. Just check this out. Is it coming out to be 0.36? Is it coming out to be 0.36, my dear students? Yes, so very good. So because the value is less than 1, that means it will be compressed, it will be diminished, because the value is less than 1. Yes, the answer should be 0.36. Are you now getting a hang of how to use the lens formula and also find any kind of magnification whatsoever? Yes, Alekhya, the answer is 3. Very good. Shaktika, very good. Sanvi, awesome, awesome. Shaheen, sorry. Yes, Sneha, very good, very good. Many of you got the answer before. Very nice. Let's go to another question which came in AIMS, and then we can go to the previous question. This question came in AIMS. Beautiful question. Find the focal length of the lens if the magnification is negative 0.5. The magnification is already given. Focal length has to be found out. Object distance is also given. Okay, let's try to understand this question. The rays from the object will come like this. That means this is the positive side. That means this is the negative side. Okay. That means the object distance will be minus 20. Image distance is not given, but magnification is given. Usually this magnification is the lateral magnification if they don't use any longitudinal or lateral word. What's the formula for magnification? I think I know it. Magnification is V by U. But the value is given to be minus 0.5. That means minus 1 by 2. V, I don't know. U, well, I know it from here. It is nothing but minus 20. Minus minus cancels. 2 cancels. 1 is equal to V by 10. So V will be plus 10 centimeters. I got the image distance. Everybody with me? I got the image distance. How much did it come out to be? Plus 10 centimeters. Oh, what do I do now? Don't have to worry. I can just use lens formula. 1 by V minus 1 by U is 1 by F to find the focal length. V value plus 10. Already got it with the correct sign. U value minus 20 because it is on the negative side. So minus 20 is 1 by F. So therefore 1 by F will be minus minus becomes plus. 1 by 10 plus 1 by 20, LCM is 20. So 10 goes with 20 2 times and this is 1. So this will be 3 by 20. So focal length will be 20 by 3 centimeters. 20 by 3. How much is it? 6.66? 6.66 centimeters. Yes, perfect. We got the answer. 20 by 3 is 6.66 centimeters, of course. Very nice. So this was a AIMS question in 2019. AIMS questions also can be solved. And if you know the formulas, when to use what, if you know the sign convention, that's it. Write down what is given, write down what you don't know. Somehow you might have to use more than one step or one formula to get the answer. I hope this has been now made as an easy question. Yes. A for Champa from AIMS. Pandu is saying A is Champa from AIMS. Yes, Champa is going to AIMS. Pandu will also follow and make the AIM dream successful. Let's go to this question now. There are 2 point light sources 24 centimeters apart. Where should a convex lens of focal length 9 be put in between them from one source so that the images of both the sources are formed on the same place? Okay. So I will just make you visualize this. The convex lens is in between them. This is that convex lens, L. One of the source is over here. Another source is over here. I can treat this as object 1. I can treat this as object 2. They both are 24 centimeters apart. They both are 24 centimeters apart. It is clearly mentioned. Okay, this is 24. This is 24. Convex lens of focal length of how much? Focal length. Focal length, how much? 9 centimeters is used in between them so that the image is formed at the same place. So that the image is formed at the same place. So if this I assume it as x distance, won't this distance be 24 minus x? Won't this distance be 24 minus x, my dear warriors? Think about it. This distance will be 24 minus x. Till this point everything is clear. X and 24 minus x. Everybody with me on this? Very good, very good. So now for the first time and the second time, I will use lens formula and I'll make sure that the image is formed over here only, at the same place. Image is formed at the same place. That's what I will assume. And because that is what is given, the image are formed at the same place. That's what it says. It's formed at the same place. So for the first time, when I take this as object and this as image, using lens formula, 1 by V minus 1 by, or I can just call it as V1, 1 by V minus 1 by U is minus X, Y minus X, Y minus X, because this is negative side, that is positive side. This is negative side, that is positive side. Everybody agrees or disagrees? Got it? Everyone? So what is V1? V1 is basically this distance. V1 is basically this distance. Cool. Is equal to 1 by F. F is basically plus 9. Cool. So therefore, 1 by V1 is equal to 1 by 9 minus, because minus minus is plus, goes on the other side as minus. So that is 1 by V1. For the next one, for object number 2, if I apply same lens formula, 1 by V1, V1 will be on the negative side, because for this object, rays will go like that. This will be positive, this will be negative. For object 2, this will be positive, this will be negative. So image distance is negative. So this will be minus V1 minus 1 by U. U is also negative because it is on the same side. So minus 24 minus X is equal to 1 by 9. So what will I get? If I write 1 by V1, 1 by V1 goes on the other side, minus minus becomes plus. So it will be 1 by 24 minus X, 1 by 9 comes over here. That's what I get 1 by V1 as. So 1 by V1 is this, 1 by V1 is also this. So obviously the next step will be combining both of them together. Obviously the next step will be to combine both of them together and see what do you get. So 1 by 9 minus 1 by X is equal to 1 by 24 minus X minus 1 by 9. Take LCM, you will get X minus 9 by 9X is equal to 9 minus 24 minus X divided by 24 minus X into 9. 9 cancels. So X minus 9 by X is equal to 24 minus, or 9 minus 24, guys, it's minus 15, minus minus becomes plus. So X minus 15 upon 24 minus X. Now you just cross multiply. So you'll get X minus 9 into 24 minus X is equal to X into X minus 15. Now this will be a quadratic equation. You will get two solutions. Choose the only solution which will match the answer. Choose the only solution which will match the answer. Just check and see if it is coming out to be 6 centimeters. One of the solution will be 6 centimeters. Other solution will not match with any of the options. So it's a slightly lengthy question. It's a slightly lengthy question, but it's a good question. It's a good question. Why? Because you have to use lens formula 2 times, number 1. Second thing is the sign convention changed, because when you use this as the object, this side is positive, this side is negative. When you use this as the object, this is positive, that is negative. So here this V1 will become minus V1. That's the catch, because of the sign convention inversion. I don't know V1. So from both these equations, I eliminated 1 by V1 and just equated the RHS on both sides. Kept solving it till I get the final quadratic equation with 2 answers. And then I match it. Other way to solve this question is, some of you already mentioned it in the chat box, hit and trial method. You don't even have to solve this completely, just use hit and trial. Just try all the options one by one, it will be very easy. It's not that difficult values also. 6 is there, 9 is there, 12 is there, 15 is there. So 6 minus 9 minus 3, 24 minus 6, 18, x is 6, x minus 15, that's 3. So just try out the multiplication, it will be very, very easy. That's all. Okay, so I hope this is clear. Then we can go to the next part. Okay, moving on to the next part, my dear students, get ready for it. Get ready for it. Everybody with me on this? Everybody with me on this? Cool. Let's begin with the combination of lens, then we'll go to prisms, and then we'll go to optical instruments. That's the flow of today's lecture. Now, see, when you have one lens and then next lens and then another lens and so on and so forth, something like that, placed one after the other, but there is some gap between them, and you have an object here. That object might make an image. That object might make an image due to the first lens. That image will behave like the object for the next lens, and that object will produce an image. That object will produce an image formed by the next lens. That image will become the object for the next lens, and finally you will get that image, which is your final image. So this object is actually the first object producing first image, which behaves like the next object producing next image, behaving like the next object producing the image. So if lenses are combined, but they are separated, then use lens formula as many times as the number of lenses and image of one is the object of the next one. Image of any lens is the object for the next lens. That is the procedure which you will use for such problems where the lenses are separated by some distance. But when the lenses are combined together, as in they are in contact, something like this. These are thin lenses in contact. When that happens, only then you can convert them into one equivalent lens. Only when they are in contact, not when they are separated. Don't do that. Only when they are in contact, you can convert it into an equivalent lens. And the formula for doing that is as simple as this. You take their powers and add them, you get the effective power. And we know power is 1 by f. So 1 by f1 plus 1 by f2 like that will be 1 by f effective. That's it. 1 by f1 plus 1 by f2 like that is 1 by f effective. So this is the formula which you use for combining the lenses together. Which are in contact. The powers get added, focal lengths reciprocal get added like resistors in parallel. Just like resistors in parallel. Cool? Okay. So with this, let's use these techniques in solving some questions. Okay. Here is the first question coming up on your screen. If you take a lens and you break it into two parts, like this. If the original lens had focal length of f, what do you think is the focal length of each of these lenses? Come on, answer in the chat box. You take a lens of focal length f, you break it into two parts like this, they become two plano-convex lenses. What do you think is the focal length of each of these lenses? If you give me the answer, I will be really, really proud of you. If you guys give me the answer, I will be really, really proud of you. Come on. Think, and tell me the answer. What do you think? Okay, I'll give you a hint. Won't these two lenses, if they have focal lengths f1 and f1, if I add them together, I will get back the original lens. So this is equivalent. So 1 by f will be 1 by f1 plus 1 by f2. So, sorry, not f2, this in this case is f1 only because they both are equal. So it will become 2 by f1 is 1 by f. So cross multiply, f1 will become 2f. Crazy. It becomes double, and many of you thought it will become half or same. No, it becomes double, and I think Alekhya was the one to answer it correctly. Very good issue. Yes. So it becomes double. So a lot of people think that it should become half. No. You know what becomes half? What becomes half? The power. If the power is p, then this power will be p by 2, this will be p by 2. But if the focal length is f, then this will become 2f and 2f, because powers get added, focal lengths, reciprocals get added. Understand that. So very interesting question. Many students make a mistake. Okay, so let's do another question coming up on your screen. This is again on cutting of lenses. I cut the lens into two parts like this. I cut the lens into two parts like this. Think and quickly tell me what will be the focal length of each of these lenses. Focal length of each. How much do you think it is? I cut it like that. I have cut it like that. Come on, my dear students. What do you think is the answer? Same, Paka, sure. Very good. Proud of all of you. This will be F only. This will not do anything because R1, R2 are the same. R1, R2 are the same. Medium is the same. Nothing will happen. So focal length remains the same when you cut it like this. There is no damage to the lens. The only problem happens when you cut it like this. When you cut it like this, then nothing changes because the rays of the lens, which are passing through the lens, whether you take the rays which are going from the top or from the bottom, will eventually meet here. Whether you take it from this top or this bottom, they will meet here. So whether you take this part or the lower part, the image will be formed at the same point. So focal length will not change. So that's why the answer is the same. Very nice. Cool. So let's do a question coming up on your screen. A convex lens of focal length 20 and concave lens of focal length 5 are kept on the same axis, and d is the distance between them. So there is a convex lens, there is a concave lens, and the distance between them is basically d. If there is a parallel beam of light falling on A and leaves B parallelly, that means if the rays fall like this, it comes out also parallel. What do you think this distance is? If you answer this, I'll be really proud, because this kind of question has come, previously also. And then not just in NEET, but also in JEE, this kind of things have come. Yeah, the image will be less bright, Shatika, because you are using fewer rays. Obviously, more rays means more intense beam. So less rays means less intense beam. Yeah, the image will be dim. That's right. Okay. So what do you think is the answer for this? I would say go by hit and trial. That will be very easy. Try to visualize how can you make them combine and again emerge parallelly. I think their focal points must coincide. That is the trick for solving this question. So if this is the convex lens and this is the parallel beam of light which is incident, the convex lens focal length is 20. So they will try to meet at 20 centimeters. So this will be 20 centimeters. But for the concave lens, focal length is 5. And I know if the rays on a concave lens are coming towards the focus, then they become parallel after emerging out. So what if I show the concave lens right over here such that the concave lens right over here such that this is 5. So this becomes the focal point of the concave, and if the rays are directed towards the focal point after emerging out, they become parallel. So parallel beam has come out parallelly. That's it. So what's the distance between them? That is obviously 15 centimeters. 20 minus 5, which is D for doctor, which is 15 centimeters. Everyone with me on this? Clearo. Very nice. Kudos. Let's now go to one more question. I'll just write it down for you. Example. If a concave lens of focal length 20 centimeters is combined with convex lens of focal length 30 centimeters, then the effective power is how much? That's the question. What is the effective power of the combination? Come on, my dear students, let's try to solve this. Tharan, Nitharan. So due to health issues, if you have started the late preparation and if you think that you can complete it by 12th of March, that is perfectly okay. You will still get 1.5 months for your final revision, although it is not the best thing that you can do, but yeah, that is the only thing which you can do. But do not exceed beyond March. At no cost, complete your portion in April. Try to finish your portion much before April only. Okay, if you want to sleep less, that's okay. You want to cover up high weightage first, that's also okay. But preferably go with the sequential order. And if there is some topic which is of very low weightage and independent, you can skip it and come to it later on. But try to go sequentially, especially high weightage, and then the low weightage independent chapters you can do it later on. Okay, so let's try to do this. What do we do? I think we need to use 1 by effective focal length is 1 by f1 plus 1 by f2. What is f1? It's a concave. Concave means diverging. Diverging means negative. So this will be minus 20 plus 1 by convex means converging. That means this will be plus 30. So this will be 1 by 30 minus 1 by 20. So LCM is 60. 30 goes with 60 how many times? 2 times. 20 goes with 60 how many times? 3 times. So this will become minus 1 by 60. So effective focal length will be minus 60 centimeters, which is minus 0.6 meters. Minus 0.6 meters, yes or no? But that is not the question. The question is power. Power is 1 by F. Power is 1 by F. So effective power will be 1 by F effective. So it will be 1 by, this is nothing but coming out to be negative. So minus 0.6. If you want, you can write 0.6 as 6 by 10. So it will be minus 5 by 3 diopters. Or basically 1.66 diopters, one and the same thing. But the answer is coming out negative. That means it is going to be diverging in nature. The effective lens is going to be diverging in nature. That's the meaning of this question, because it is minus. Magnitude wise 5 by 3. Yes, very good. Most of you got it. Very good, Alikia. Very good. So many of you got it. Awesome. 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 Now let's go to the part where we talk about prisms. Please remember, silvering of lenses, combination of lens with mirror has been deleted. Combination of lens with mirror has been deleted. Silvering of a lens has been deleted. So please don't waste your time solving those questions, because that is probably there for JEE, but not for NEET physics. This year you are very, very lucky for specifically the syllabus part, because half the things have been deleted. Now when you go to Prism, you know what the best part is, or I don't know what the worst part is. Dispersion has been deleted. Dispersion only they deleted. Crazy. And I made a video also on that just few days back to tell you, which all parts have been deleted and not deleted. How many of you have seen that? How many of you have seen that? How many of you have basically seen that? So you would have noticed that yes, there is no more dispersion. There is no more dispersion. There is no more combination of lens with mirror or silvering. So that makes our job really, really easy. Very good. But let me just explain what dispersion is, and then we'll go to Prism, because I feel that is something interesting. You will love it and enjoy it also. And it's very, very nice to see in the diagram also. So let's say, for example, my dear students, there is a surface over here, or there is a surface over here. It's a interface. It's an interface. I hope you are able to see this. Yeah. Okay. Very good. Okay. Very good. And imagine you pass in white colored light. White colored light. When I say white light, is it a color? Is white light actually a color? Is white light actually a color? Because if you see violet color light, it's a very, very short wavelength. This is violet. Then as you slowly go towards blue, the wavelength becomes slightly longer, right? And then as you go towards green, it becomes slightly even longer. Then when you go to yellow, even longer, and then orange, even longer, and then red, even longer. That's how the wavelength changes. So red, wavelength of red, frequency of red, if you compare with that of blue or violets, wavelength of red is larger than the wavelength of violet, but frequency wise this is smaller than the frequency of violet. Speed of violet color or speed of red color, they both are the same. Speed of red color or violet color, they all move at the same speed, yes, obviously, in vacuum of course, but in mediums it will be different. So keep that in mind. But otherwise you should know wavelength and frequency of red and violet, how they compare with each other. Red has larger wavelength, violet or blues have shorter wavelength. Is this known to you? If you ever forget whether violet has more wavelength or red has more wavelength, just remember, for danger, to indicate danger, warning, which color do you use? Something bad is there. Maybe there is a big hole on the road. So you put something, and which color do you use to indicate danger? Or if there is a train or bus or car standing, which color of light is used so that nobody comes and hits it from behind? It's red, right? Very good. So red is seen from a longer distance. Red is seen from a longer distance, so longer wavelength. That way if you remember, it will be very easy. That way if you remember, it will be very, very easy. Is that clear, my dear students? Okay, very good. So now it so happens that white is not a wavelength, it's a mixture of colors. Violet, indigo, blue, green, yellow, orange, red, and so many colors in between. So many colors together, if you mix them, what you see in your brain is basically white color. And when white colored light hits a surface, the light ray will bend. Do not expect the white light to bend like this. No. Reason is, in that white, because it has violets, reds, etc., each color only has different refractive index. Each color only has different refractive index. So That's the reason why you will see different amount of bending in each one of them. And what you see is basically, is the red color bends the least, then orange and all of that. Then you have your yellow. Something like this. This is how the bending occurs. So who bent the most? Who bent the most? Which color bends the most? Thank you, Taran. Which color bends the most, my dear warriors? Yes, violet. Which color bends the least? Red. So remember this: violet, indigo, blue, green, yellow, orange, red, Vibgyor. Violet, indigo, blue, green, yellow, orange, red. That's how the colors are separated. This phenomena only is called as dispersion. And why does dispersion happen? Due to different refractive indices for colors, for different colors. So from this, who has the highest refractive index and who has the lowest refractive index? Obviously, red has lowest, violet has the most because it bends the most. So if you have to compare, mu of red is the least. Then yellow is also considered as the mean color. This is also called as the average or the mean color. So yellow is slightly higher, and violet has the highest refractive index. Mu is the highest. Keep this in mind. You can also see deviation of violet is more. Violet deviated more than yellow, which deviated more than your red color. And because it is the mean color, yellow one, so hence also you will see refractive index of the yellow color is actually the average of the violet color and the red color. Is actually the average of the violet color and the red color's refractive index. So these are the important things that you should just know. It will not come in the exam, I'm pretty sure, because it has been deleted, but just telling this to you out of interest and just for general knowledge. Okay, just in case. Till this point everything is clear? What is dispersion? It is the splitting of color from its constituents into its constituents when the medium changes, and that happens because of different refractive indices. And the yellow is the between color, which is also called as the mean color or average color. Average means literally average of the extreme colors, which is violet and red's refractive index. That is what you should know about dispersion. Now, what you should know in prisms is just the prism optics part. So what is this prism optics? Let's have a look. Observe this. What is a prism? Is this a prism? Yes. Is this a prism? Yes. Is this a prism? Definitely it is. Is this a prism? Definitely it is. Is this a prism? The answer is yes. Basically, what should happen is, if a light enters in, refracts, there must be two surfaces which are at an angle. Light enters in, refracts, then there should be two surfaces inclined at an angle. Light enters, refracts, two surfaces which are inclined at an angle. Light enters in, refracts, two surfaces which are inclined at an angle. Light enters in, refracts, two surfaces inclined at an angle. So basically all these are prisms. Basically you should have two refracting non-parallel surfaces, then you call that as a prism. Because the moment you have parallel surfaces, it becomes a glass slab. The moment you have a parallel surface, what does it become, my dear students? It becomes a glass slab. Very good. So when you have a prism something like this, wow, beautiful prism, right? This angle on the top, which is the angle between the two surfaces which refract, that is called as the angle of prism. A is called as the angle of prism. Sometimes it is also called as refracting angle of the prism. Refracting angle of the prism. One and the same thing. So now if a light ray enters over here, maybe something like this, first thing what you will do is you will draw a normal over there. You will draw a normal over there, something like this. Then you will again see the light ray bending inside, maybe something like this. Then wherever it hits the next surface, again you will draw a normal over there, something like this. And finally you will see the ray coming out, emerging out from here. A very important diagram. Let me just duplicate this. I think I'll need it at many places. Yeah. So this angle that you see over here, usually it is marked as I1. This angle over here is usually marked I2. These internal angles R1 and R2. So what is I1? I1 is basically your incident angle on the prism. That angle I2 are basically, it is called as the emergent angle of the prism. Emergent angle of the prism. R1 and R2 are usually called as the internal refracting angles. Internal refracting angles of the prism. Is this point clear? What is what? Awesome. Now there is a relationship between all these variables. There is a relationship between all these variables, and let's try to understand what that relationship is. So let me just create a duplicate over here. Yes, that's good. If you look specifically at the internal angles, that is R1 and this as R2, and then take the complementary of them, that is over here and over here. Notice this is, the dotted line is perpendicular. So if this is R1, this will be 90 minus R1. And if this is perpendicular, this is perpendicular, this is R2, obviously the remaining angle will be 90 minus R2. And we know that in a triangle, the sum of angles is how much? 180 degrees. It is how much? 180 degrees. So this plus this plus this, won't it be 180? So A plus 90 minus R1 plus 90 minus R2, won't it be 180 degrees? So A plus 90, 180. 180 goes there. R1 and R2 go on the other side, R1 plus R2. 180 cancels. So A will be nothing but R1 plus R2. A very important relationship which you should know. The angle of the prism is the sum of the internal angles of refraction, which is R1 and R2. First result which we derived. Okay? Clear till this point? Very good. Next important thing which you should know. For any prism, whatever the angles be, you can always use Snell's law. So if you use Snell's law, you will write it like this: mu, which is the refractive index, Sine I by sine R. So this will be sine of I1 by sine of R1. And if you pass the ray from here, refracted angle will be R2, reversibility principle. That's why I did not show arrow marks, because light ray can come here also and exit out like this. Then this will be emergent, this will be incident. If it enters from here, this will be incident, this will be emergent, depending on the arrow marks, correct? So depending on the arrow marks. So if the light ray goes from there, then angle of incidence will be I2 and angle of refraction will be R2. That's one. So you can always use Snell's law. This was never a problem. I mean, Snell's law is anyways valid. Snell's law can be used depending on the problem. Can always be used depending on the problem. Keep this in mind. Another important result which you should know regarding prisms. Next important thing. Next important thing. Observe this. The incident ray which was there, had it not encountered the prism, would have gone over here, would have gone straight. But because of the prism, it tilted by some angle. So it has now got what? Deviated. What did it get? Deviated, correct. So now you will see that the ray has got deviated by some angle. It has got deviated by some angle, delta. Is this point very, very clear? How this angle of deviation has been measured? Because the ray which was supposed to go like this, because of the prism is going like that. So with reference to the incident, the refracted ray is going like that. Cool. So now if I start marking the remaining angles, this is I1, this is I2, this is R2, this is R1. Think what will delta be? The total deviation by a prism. The total deviation by a prism, delta, will be deviation in the first part. It tilted by some angle and again it tilted. We did a question just like that on sphere. There were two deviations happening and we added the deviations because they were deviating 2 times. So that's why can't I say it is delta 1 plus delta 2? First deviation, I turned by 3 degrees, then turned by 5 degrees. So first 3, then 5, total will be 8. So delta 1 plus delta 2. What is delta 1? I just told you regarding refraction, delta is I minus R, bigger minus smaller, or R minus I, depending on who is big, who is small. So won't it be I1 minus R1? Because I1 is big, R1 is small. And over here, won't it be I2 minus R2? Won't it be nothing but I2 minus R2, my dear warriors? So won't this become I1 plus I2 minus R1 plus R2? But wait a minute. R1 plus R2 is nothing but A. R1 plus R2 is nothing but A. So I1 plus I2 minus A will be delta. This is your second equation. This is your second, another equation which you should know with regards to prism. All these are non-negotiable. You have to remember the derivation. You have to know how to get it. Also the final formula. Yes, you should do the additional exercise for class 12 boards. Definitely alone. Definitely. Yeah, another important formula. Now, next one is as follows. Observe. Angle of deviation versus angle of incidence graph. If I change the angle, how much does it deviate by? I try to use Snell's law, I try to use the formulas, and for every angle I see what the final relation is, final value of delta is. That graph is very interesting in nature. That graph looks something like this, like a parabola. It looks almost like a parabola. Yes. So, interesting thing in this graph is that, for a particular delta, for a particular deviation, you will get two angles of incidence for which the deviation is same. You will get two angles for which the deviation is same. So that's what I will write down. In general, for a particular deviation, there are two angles of incidences, I1, I1. So we'll get two values of angles of incidence, except for one place, and that happens over here, and that happens over here. That is right over here. Oops, just 1 second. That happens right over here. Here is the only point where you get the minimum deviation, and this happens at a very special place where I1 is equal to I2, where basically you will see that I1 is equal to I2. And when that happens, my dear students, this is how it looks like. Maybe I can remove this. Wow. Okay, can I just remove this? Okay, and what you will see is the ray goes like this, goes flat and comes like this. This angle and this angle both are equal. This angle and this angle both are equal, and so are these two angles, because it will be a symmetric diagram. This ray comes out to be parallel to this base. This ray comes out to be parallel to that particular base. That's what you will see when the angle of deviation is the least. So this I1 and this I2 become equal. That is for minimum deviation. For minimum deviation, delta m, you will see, for minimum deviation, which is delta m, you will see I1 is equal to I2, R1 is equal to R2, and the ray in between is parallel to the base. That's what you will see. And because R1 is equal to R2, since R1 is equal to R2 and R1 plus R2 is A, therefore R1 plus R1 will be A, therefore R1 will be A by 2. Not just that, also we know delta is I1 plus I2 minus A. I1 plus I2 minus A, and I1 is equal to I2, so I1 plus I1 minus A will be the minimum deviation. So therefore, taking A on this side, delta m plus A will be 2I1. So therefore, I1 will be delta m plus A divided by 2. And then finally, using Snell's law, can I not say mu is sine I1 by sine of R1 using Snell's law? So therefore, mu will be sine of, instead of I1, I can put it as A plus delta m by 2. Instead of R1, I can put it as sine of A by 2. So that becomes the next formula for finding the refractive index if delta m is given, A is given. Or if mu is given, delta m is asked. Whatever. This is the derivation for that. Mu, refractive index, is sine of A plus minimum deviation by 2 upon sine of angle of prism by 2. A very important formula. Very, very important formula. Is that okay, everyone? All these things are very, 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 very crucial. Okay, so keep all these things in mind. All these things are not needed. Oops. I think let it be. It's okay. Fine. Now there is one last formula, and that last formula is for something called as a thin prism. So let me just draw a slide over here, and let me just show something called as a thin prism. This is basically called as a thin prism, and in a thin prism that angle is very small, like 10 degrees, 15 degrees, 2 degrees, 0.1 degree, like that. So that angle of the prism is very small. So when you pass that light ray and you see that it gets deviated, something like this. You see that it gets deviated like this, correct? If you draw the graph for deviation versus angle of incidence for a thin prism, if you draw the graph of angle of deviation versus angle of incidence for a thin prism, it looks something like this. Observe. This is your delta. This is your delta versus angle of incidence. That graph looks almost flat. Not like this, but that graph becomes almost flat. It's curved, but hardly any change. So, can I not see that in such a scenario, whichever deviation you take, it's almost the same. It's almost the same. So can I not see that delta is approximately equal to delta m for all angles of incidence, whether it is I1, I2, I3, whatever, it's almost the same, correct? So now if I know this and I also know this formula, I think I can get a short formula for thin prisms. So observe what do I get for thin prism. I don't need this. Yeah, I don't need this slide. Yeah. What formula do I get? Observe. Mu is equal to sine of A. Instead of delta m, I will just put delta and by 2 divided by sine of A by 2. Sine of A by 2. This is again not exactly equal to, but I can say this is approximately equal to, because delta is equal to delta m. But sine of a small angle is the small angle. Sine of the small angle is the small angle. Therefore, mu will be equal to A plus delta by 2 upon A by 2. 2 cancels. So therefore, mu will be A plus delta by A. Rearrange it further. A into mu is equal to A plus delta. Just shift this A over here. Next step. Delta will be A mu minus A. Therefore, deviation will be A common bracket mu minus 1. This is another important formula, but it's only for thin prism, not for anything else. It's only and only for thin prism, nothing else. So this is another derivation which can be used for your boards and also helpful for your NEET examination. Is this clear? Everybody? Cool? Understood? So we have seen a lot of formulas for prisms in general. Let's revise all of them. Snell's law, that is standard. Sin I by sin R, sin I by sin R is mu. Next thing, internal angle sum is the angle of the prism there. Next thing, the total deviation is I1 plus I2 minus the angle of prism. Next, the graph of deviation versus angle of incidence is a curved nature. Usually you get two angles for the same deviation, but only one angle for the minimum deviation. Only one angle for the minimum deviation when I1 is I2, R1 is R2, and deriving you finally get mu is sin A plus delta by 2, sin A by 2. If the prism is thin, then the graph is almost straight. The deviation is almost same for all the angles. And then you get the deviation is A into mu minus 1. That's it. These are the only things that you should know. Shall we go ahead? Shall we go ahead? Okay, let's start. Here's the first question coming up on your screen. Let's see if you guys can get it. A ray of light is incident on an equilateral prism at a grazing incidence, emerges from the prism at grazing emergence. The refractive index of the prism is straightforward, guys. Grazing incidence is given. Grazing means, what does grazing means? It's like this, goes like that, and this is like this. Oops. This is grazing incidence and grazing emergence. So in such cases, the angle of incidence is 90, angle of emergence is also 90. Angle of incidence and angle of emergence both are basically 90 degrees. Yes, my dear warriors. Come on. So now, if that's the case, the ray of light equilateral prism, okay, that is also given. Equilateral prism means A is 60 degree, but A is also R1 plus R2, but R1 and R2 both are equal because I1 is equal to I2. I1 is equal to I2 is equal to 90 degree. Why? Because of grazing incidence. Because of grazing incidence. Hence, R1 and R2 are equal. So therefore, 2R1 is 60. Therefore, R1 is 30 degree. So I know R1, I know I1. I think we can find using Snell's law the refractive index. Sine I1 by sine R1. Mu is sine I1. Sine of I1 is 90. Sine R1 is basically 30. Sine 90 is 1, sine 30 is half. So 2 goes on the top, mu is 2. So that is option number 4. Option number 4 is 2. Yes, that's the correct one. That is the correct one. Got it? Everyone with me? Cool. Shall we go ahead to the next part? Shall we go ahead to the next part? Okay. Coming up on your screen, and here it is. Find the value. This is NEET 2021 question. Find the value of the angle of emergence from the prism. Very, very nice question. Find the angle of emergence from the prism. My dear students, in this question, can you see that the ray is normally incident, so it will continue its journey like this only. It will continue its journey like this only. Correct? It will continue its journey like this only. It will hit over here, and at that particular location, if I draw a line like this, if you find this angle, you can find out at what angle does it come out. If you find this angle, you can find the angle at which it will come out. So how do you do it? Come on, think. What geometry will you use? What geometry do you think you will use? Think you will just draw another horizontal line like this, and you will see if this is 60, this line and this line are parallel with this line cutting through it. So naturally this angle will also be 60 degree. If this is 60, this is 60, alternate angles, right? Something like this. This angle is equal to this angle. This angle is equal to this angle, correct? So this is 60. So naturally this angle will be 30 degree. This angle will be 30 degree. Now you see these two are parallel lines. This is 30. So this is also 30. That's it. So you have two parallel lines. This is the line. If this is 30, naturally this will be also 30. So hence this angle is going to be 30 degrees. Finally, your ray will come out of this. Finally, your ray will come out of this at some angle. And I want to find the angle of emergence, that angle of emergence Z. So what do? Use Snell's law. You can use reversibility. If the ray enters in and goes in like that, also the ray diagram will be the same. So if you write mu value, it will be sine of E divided by sine of R, which is 30 degree. make the ray go in. Why? Because if it is coming out, it is going from dense to rare, and refractive index is given for rare to dense. This refractive index is always generally given for rare medium to dense medium, not dense to rare. So I just flipped the diagram. Correct? So mu value is √3. Sine of E I don't know. Sine 30 is half. So it goes on the top. It becomes √3 by 2 is sine of E. Naturally, E will be how much? 60 degree. Sine 60 is √3 by 2. That is the answer. Such a nice question which has come geometry based in NEET 2021. It's a very recent question. Just had to use Snell's law and little bit of geometry here and there. Moving on to the next question coming up on your screen. The angle of minimum deviation is equal to the angle of the prism A. The angle of the incidence at which minimum deviation will be obtained. Complete word problem. Always try to write what is given in mathematical form or a diagrammatical form and then solve the question. Equilateral prism. First statement, A is basically 60 degree. Next statement, minimum deviation is equal to the angle of prism. So delta M is equal to A, which is again equal to 60 degree. Then the angle of incidence at which minimum deviation will occur. That means I1 is asked. What is asked? I1 is asked. Is there a formula which I already know? I think we know that. Delta is I1 plus I2 minus A. But since minimum deviation is given, that means I1 will be equal to I2. So instead of I2, just put it as I1 only. And delta is 60. I1 plus I1, that is 2I1. A is also 60. So this will become 2 times of 60 will be 2 times of I1. Therefore, I1 will be 60 degree. 60 degree is option A for AIMS. Yes, it is A for AIMS. You can see that. Correct. Right, everyone? Yes, Alekhya, that's the correct one. Moving on to the next question coming up on your screen. And here it is. Light ray is passing through a thin prism, separate formulas. Angle is 8. Refractive index if deviation is 2. For thin prism, deviation is A into mu minus 1. Deviation is 2 degree. Angle of prism is 8 degree. Is mu minus 1. So 2 by 8 is 1 by 4. Is mu minus 1. So therefore mu will be 1 plus 1 by 4, which is 5 by 4. How much that is? That is nothing but 1.25. So where is it? 1.25 C for Captain Shreyas. 1.25 C for Captain Shreyas. Direct formula based questions do come in the NEET exam. My dear students, are you now confident? Because we are going to go to the next part and dispersion is deleted. So let's just skip that. Where did we go? Oh my God, wait. It acts very weird at times. Yeah. So we have to go to optical instruments. Correct. So let's begin with the last part, and that is optical instruments. Are you ready? No break, because we are going to hardly take 15 minutes now. Are you ready to stay awake for 15 minutes? Yes. So let's begin. Dispersion, Seha, is not there. Why do you want to study when it is not there? Okay, but I told you about dispersion at the beginning. So please watch that starting part. You'll understand it. Don't study dispersion for NEET. It is deleted. Completely deleted. When did I tell adding experiment? Which adding experiment? No, that deviation without dispersion and all that is not there. Dispersion only is not there. Complete dispersion. So the combination of prisms is also not there. Don't waste your time. Okay. So I know in the coaching, maybe if you would have done it long time back, it would have been taught, because that time the syllabus was not announced, but the syllabus was announced very recently. So please remember, certain aspects are deleted. It might be there in boards, it might not be there in NEET. It might be in NEET, but not in boards. So be very careful when you are solving questions. It might be in boards. In your board, it might be there, but in the NEET exam, it might not be there. You might have done it last year, but now it is not there. Got it? So that dispersion without deviation, deviation without dispersion, dispersive power, omega, dispersion angle, all those things are deleted. Don't waste your time. Okay, let's have a look at optical instruments now. See, if this is a beautiful champa and Pandu wants to examine her, Pandu wants to see her. As champa comes close, champa looks bigger and bigger. Reason is very simple. If champa is here versus champa is far away, the angle is different. The angle subtended is different. So can I say the size and clarity of an object or an image depends on the angle subtended, at the eye. Everybody agrees with this? More the angle, the better it is. So this case is better, whereas this case, as you go far away, the angle, the angle is less. You can see the size perceived is less. So when you see a big building from very far away, it looks small, it's not so clear. But when you come closer, the angle subtended is huge, it looks much bigger. So what is the job of an optical instrument? Why an optical instrument? Observe this. See, if you bring an object closer and closer and closer to the eye, there is a point till which you can bring it close. After that, if you bring it close, it will not become more clear from your human eye, and that distance at which you can keep it and it is still clear, that distance is called as capital D, which is your least distance of distinct vision. Least distance of distinct vision. Least distance of distinct vision. That's the closest. From the eye when it is clearly seen. This is when it is at the least distance of distinct vision. Correct. So below this, you will not be able to see it clearly, and at that very instant, the angle which is subtended with the eye, I will call it as theta naught. So I can say theta naught is the maximum angle for an unaided eye, which is subtended. Unaided means you are not taking help. Aid means you are taking help, like a magnifying glass, microscope, telescope. You are not taking help, that's why unaided. Theta naught is the maximum angle that you can subtend at the human eye level, beyond which you will not be able to see the object clearly, because human eye also has limitations. It cannot focus below certain distance. Usually usually the value of D is roughly 25 centimeters. How much is it? Roughly 25 centimeters. We'll try to complete as much as possible by February, March. February, March, it will be done. We'll not extend it beyond that. Okay, cool. Now, if this is clear, understand, if I take help of an instrument, this is some instrument, I don't know, it could be some telescope, microscope, whatever it is. I have an object here, and finally what happens? There is an image which is formed. There is an image which is formed over here. This is nothing but your image which is formed. This was the object which was placed. Then at the human eye level, if you see using that optical instrument, whether it's magnifying glass or anything else, then you might now probably see that image at a much larger angle. You might see that image at a much larger or a different angle. Let's say I call it as theta. So theta is the angle subtended by an aided eye. Aided eye. This is very important. Aid is there. Aid means you have taken help. You have taken help of an optical instrument. Optical instrument. Then your theta might be larger than theta naught. Else what's the use? If the minimum angle, the maximum angle that an unaided eye can subtend was 5 degrees, with the help of an optical instrument, if that 5 degree can be made as 15 degree, that's a very good instrument. I made that image look 3 times larger because the angle has been magnified 3 times. So then you call something called as the magnifying power. Then you write something called as the magnifying power. Magnifying power. Magnifying power. And that magnifying power is this particular theta, which is subtended by the aided eye, upon theta naught, which is the angle subtended for an unaided eye. This is a very, very important formula. Now please remember, this magnifying power is dimensionless. It's not the same. It's not the same as power. Power was diopters, 1 by f. Completely different. Magnifying power is like 5x, 3x, 2x, 100x. 100x means 1 degree will be made 100 degree. 0.1 degree will be made 10 degree. 2x means 1 degree will be made 2 degree. That's the number of times the angle will be magnified. Don't get confused between just power. Is that clear? Yes. Is that clear? Yes. Awesome. Awesome. I'll be conducting a special class only for experimental physics. Don't worry about it. For now, just focus on this. So now that you understand what magnifying power is and what least distance of distinct vision is, we use, or we have 3 optical instruments which you should know for NEET syllabus. The first one is called as a simple magnifying glass, or a simple microscope, magnifying glass or a simple microscope, where you use a convex lens, you place an object before the focal point, and you see that there is a nice large image which is formed, which is virtual. This image is, call it virtual, it is erect, and it is magnified. And it is magnified. And this image might subtend. This image might subtend some angle at the human eye level, right? And measuring that angle and then doing all the comparisons, you get the formula for magnifying power for a simple microscope. You don't have to worry about the derivation in NEET perspective, only remember the formula. The magnifying power is there for two different cases. What are the two different cases? First case, the image is at least distance of distinct vision. That means it is very, very close for you. And the second case is when the image is formed very far away from you. That means your eyes are relaxed. Eyes are basically relaxed. So in the case it is relaxed, it is called as normal vision. That means the eyes are relaxed. And when it is at least distance of distinct vision, then it is completely under strain. Your eyes are under strain when things are close, eyes are relaxed when things are far. When it is relaxed, the magnifying power is D by F. The magnifying power is D by F. And when it is strained, or it is at least distance of distinct vision, it is 1 plus D by F. These are the two important formulas which you must know. Which you must know. Is that clear, my dear students? This was your object. So the object is placed before the focus, only then you will get a virtual erect magnified image. So when it is relaxed, then it is this. Okay, so you should know that also. And when it is strained, then it is 1 plus D by F. Clear? Don't have to remember how to get the formulas. That is not there for NEET. Don't waste your time in such things. Direct formula questions will come. Example, find magnifying power of a glass having focal length 5 centimeters. Come on, figure this out. For least distance of distinct vision. For least distance of distinct vision, directly a simple question can come. Find the magnifying power of a magnifying glass having focal length 5 centimeters for least distance of distinct vision. Magnifying power for least distance of distinct vision is 1 plus D by F. D is 25, focal length is 5. So 25 by 5 is 5, 1 plus 5 is 6. So 6x or 6 times is the magnifying power. 6 is the magnifying power directly. Direct questions come, you don't even have to break your head. Cool? That's a simple microscope. Then you have a normal microscope or just a compound microscope. Compound microscope, which is used in your laboratory to study blood cell, hair tissues, cells, or some bacteria, fungus, etc. You make a slide, put it under the microscope, adjust it, and then see, the magnified image of that organism. So in such case, you generally have two lenses. Like this. This lens is called objective because object is placed near it. This is called as the eyepiece. This is called as the eyepiece because your human eye is near that. Your human eye is here. And the object, just like over here, was placed here and you get the image. Same way, you will see that in this situation, you will see that the object is placed somewhere here. That's why this lens is called as objective. Usually it is placed very close to the focal point, of the objective. So this is the focal point of the objective. So what happens when the object is very close to the focal point but slightly beyond it, the image goes very far away. Image is formed really far away because of that. And you will see that an intermediate image is formed somewhere here, which is inverted in nature, which is inverted in nature. This is your intermediate image, of objective, which behaves as the object for the eyepiece, which behaves like the object for the eyepiece. And the lenses are so adjusted, the distance between the lenses are so adjusted in such a beautiful manner that this image, which is intermediate, comes slightly before the focal point of the eyepiece, before the focal point of the eyepiece, because of which this eyepiece behaves like a simple microscope, not compound, simple microscope. Remember, in simple microscope, object is placed just before the focal length. You get a erect, magnified, enlarged image, right? Virtual image. So you will see an erect. This is already inverted, so it will be inverted only. So you'll get a large image right over here. You'll probably get an image something like this, somewhere here. This is your final image which is formed. And then you can say that this is subtending certain angle. This is subtending certain angle, let's say theta. And dividing that theta by theta naught, again you get the magnifying power. Again, what do you get? You get the magnifying power. That's all. So the magnifying power is generally given as, there are two terms here. You multiply it with two things. First term is magnification, not magnifying power, magnification of objective, that is this one, multiplied by magnifying power of eyepiece, multiplied by magnifying power of eyepiece. Now think about it. What are these two terms going to be? What are these two terms going to be? Let me explain this in detail. If you go for magnifying power of the eyepiece, it will be either d by f or it will be 1 plus d by f, depending on whether it is normal vision or whether it is least distance of distinct vision. Depending on normal or least distance of distinct vision, this will be d by f or 1 plus d by f. This focal length will be of the eyepiece. This focal length will be of the eyepiece. Everybody clear till this point? This part, it's a multiplication of two numbers. It's a multiplication of two numbers. Keep this in mind. And this part, magnification of objective. Observe this now. This is a standard formula. What is magnification formula? What is magnification formula for any lens? It is V by U. So it is V by U, but this V is nothing but the image distance from the objective, and this U is the object distance from the objective. V by U, but everything measured from the objective lens. Yes or no? But if you notice this entire diagram, you will realize that the image is formed really far away, almost closer to the eyepiece. It's very close to the eyepiece. So the image distance is almost the length. So can I not say this is approximately, most of the times this is nothing but L. This distance is image distance from the objective is almost the length. This is very less, and the object distance from the objective is almost the focal length of the objective. So won't this be FO? So hence the magnifying power will become L by FO into D by FE or 1 plus D by FE. That's all. That's a simple mind map to remember this formula. This is a simple mind map to remember this formula. Is this clear? Is this understood? Let me know in the chat box. Let me know in the chat box if you guys have understood. Like for example, they can give you the length of the microscope. Length of the microscope is 40 centimeters, and the focal lengths of objective and eyepiece are 2 centimeter and 5 centimeter. For least distance of distinct vision, find the magnifying power. Find the magnifying power. This is the question. What is the magnifying power formula? It's a multiplication of two things. So the magnifying power is magnification of the microscope. Magnification of the microscope's objective, multiplied by magnifying power of the eyepiece. Magnification of objective, like I told you before, is VO by UO, which is L by FO, which is nothing but L by FO, multiplied by magnifying power of the eyepiece. Either use this or this, but for LDDV, it is 1 plus D by FE. It is 1 plus D by FE. That's it. Oh, I think everything is given. We can start solving the question. So what is L? L is nothing but 40. What is FO? It is nothing but 2. 1 plus D is 25 divided by FE. What is FE? FE is nothing but 5. So this will become 40 by 2, which is 20, into 1 plus 25 by 5 is 5. So it will become 20 into 6. So the magnifying power will be 120 times. It will be 120 times magnified. That's how you got the answer. Beautiful question. Beautiful question. Is that right, everyone? Understood? Clear? Okay. So I explained you very well when to use what formula. You can never go wrong if you remember it this way. Now the last one, and that is a telescope. So I will tell you about the telescope also. So again, you will have two lenses. One is objective, one is eyepiece. This is your eyepiece. This is your objective. This is the distance between them. So that would be L. That would be L. Your object will be really, really far away. Your object. Obviously, telescope, what do you see? Not an organism. You will see a star, moon, sun, other planet, which is really far. So this distance is really, really far. It is almost infinity. So the rays will almost come parallel. And you will see that a small image is formed. Right over here, which is, it has generally a small focal length. This is a intermediate image, small, inverted, real image by the objective, which now behaves like the object for the eyepiece. And because the rays are parallel, you will see the image will be formed. Very close to the focal point. So focal point, and that image will be very close because the rays will almost meet at the focal point. This image is now made sure that it is also before the focal length of the eyepiece. Because if you put an object before the focus for a convex lens, the image becomes erect, magnified and virtual. So you will see this image will get magnified. It will get magnified, maybe something like this. You might get a large image somewhere really far, something like this. This is also very, very far. This is your final image, which is virtual. It is inverted as respect to the initial one. It is inverted as respect to the initial one, and it is also magnified. It is also magnified in nature. That's how you do it. And here you will see that the focal length of objective and the focal length of the eyepiece, because their focal points coincide almost, this length plus this length together will give you the length of the tube. So you can also write L is F0 plus Fe. This is one very important relationship which you should know. This is one very important relationship which you should definitely know, because you can see this one is FO and this one will be Fe. If you add both of them, you will get the total length. Not just that, the magnifying power formula. The magnifying power formula. Here you don't have two cases because you don't want the planet which you are seeing very close to your eyes. Even if it is far away, you are okay with it. Even if it is far away, you are okay with it. So it is for normal vision. Hence, it is nothing but Fe by Fo. That's all. Fe by Fo. And this is always for normal vision, not for least distance of distinct vision. Always this one. So keep this formula also in mind. This is for telescope. Fe by Fo. Is that okay? Shall we do some questions now? The last few questions coming up on your screen, and here it is. If there is a telescope having large magnification and high angular resolution, I think this part has been removed because resolution has been deleted from the syllabus. Let me just go directly over here. Yeah, the length of a telescope is 90 centimeter, magnifying power is 17, focal length of eyepiece and objective are. Let's try to understand what and all is given. The length of the tube is basically 90 centimeter. Okay, magnifying power is 17. Length is F0 plus Fe, so that is 90, and magnifying power Fe by Fo by Fe, that is basically 17, correct? Fo by Fe is basically 17. So from this, Fo is 17 times of Fe, is 17 times of Fe. I can just rearrange the terms. So take this and put it here. So I'll get 17 Fe plus Fe is basically 90. So 18 Fe is basically 90. So Fe, 18 5s are 90. So Fe is 5 centimeters and Fo is 17 times of 5, which is 85 centimeters. So 5 and 85 centimeters, that should be the answer. Yes, that should be the answer of it. Eyepiece is 5 centimeters, objective is 85, not 85 and 5, because that is not in the right order. So these kind of questions do come in the examination. That's all that is there, my dear students. And let me tell you, there is also a practice quiz below this video. So make sure you solve this. This is like your DPP. And you will be also getting the PDF on our Telegram channel. This entire optics has been done with respect to the new syllabus. Keep in mind, many things are deleted, so we have omitted it from this class because that is not at all useful for your examination. Okay, so if you have watched both Ray Optics 1 and 2, please put it up in the comment section. Optics Seesaw. Optics Seesaw. I want everybody to comment on this, and I want to see and read all those names who completed this chapter, and I want to see who watched this video till the end. Okay, so thank you very much. Yes, that's all that is there. So Sneha, what else you want in telescope, please let me know, because if you have a doubt, you can just contact me on Telegram also, Captain Shreyas for NEET. That's our Telegram group. And also, if you want, you can watch the replay of the part which you missed maybe you will understand it again. Cool. Just watch it. 100% you'll get to know. Okay? Or leave a comment below. I will definitely respond to it. Thank you very much. Have a great time. Have your dinner. And finally done with optics. We'll start with the next chapter tomorrow. Okay? Bye bye. Take care. Hasta la vista.